Inheritance in Java is a mechanism in which one object acquires all the properties and the behaviors of a parent object. It is an important part of object-oriented programming system. We can use a unified modeling language, a class diagram, to visualize an overview of a class. It consists of a rectangle divided into 3 sections. The top section contains the name of the class. The middle section contains the names and the data types of the attributes, and the bottom section contains the methods. Only the method return type, name, and arguments are provided in the diagram. The instructions that make up the method body are omitted. In this example, we have an employee class, and the attributes is one is an integer ID, the other one is a double salary. The 4 methods get ID, which has no arguments, and the return type is integer. Get salary, no arguments, return type double. Set ID. For the argument, it receives an integer ID number, and it returns nothing, so it's a void. Set salary also receives one double parameter as a salary, and it is void method. Suppose that you hire a new type of employee, such as a salesperson or service representative, that requires not only an ID number and a salary, but also a data field to indicate the territory served. You can create a class with a name such as an employee with a territory and provide the class 3 fields, ID, salary, and a territory, and the 6 method, get method, and the set method for each of the 3 fields. When you do this, however, you are duplicating much of the work that you already have done for the employee class. The wise, efficient way is to create the class employee with territory so it inherits all the attributes and the methods of employee. Then you can add just the 1 field and the 2 methods that are new within employee with territory object. Though in this figure, it shows a class diagram of the 2 classes and their relationship. The Unified Modeling Language, UML, the diagram of inheritance relationship is indicated with an arrow that points from the descendant class to the original class. The idea behind inheritance in Java is that you can create new classes that are built upon existing classes. When you inherit from existing class, you can reuse methods and the fields of the parent class. Moreover, you can add new methods and fields in your current class also. Inheritance represents the is-a relationship, which is also known as a parent-child relationship. A class that is used as a basis for inheritance, such as an employee, is a base class. When you create a class that inherits from a base class, such as an employee with territory, it is a derived class. When considering 2 classes that inherit from each other, you can tell which is the base class and which is the derived class by using the 2 classes in the sentence with the phrase is and. A derived class always is a case or example of the more general base class. For example, a tree class can be a base class to an evergreen class. An evergreen is a tree, so tree is the base class. However, it is not true for all trees that tree is an evergreen. Similarly, an employee with territory is an employee, but not the other way around. So employee is the base class. Don't confuse is-a situations with has-a situation. Is-a describe inheritance, but has-a describe containment. For example, we can say each department object might contain an array of employee objects, though in this case, you wouldn't say an employee is a department, but you would say a department has employees. So this relationship is not inheritance. It is a specific type of a containment known as an aggregation, the relation in which a class contains one or more members of another class. You can use the terms superclass and the subclass, similarly as for the base class and the derived class. Evergreen can be called a subclass of the tree superclass. You can also use the terms parent class and the child class. An employee with a territory is a child to the employee class parent. You use the keywords extend to achieve inheritance in Java. For example, the following class header creates a superclass-subclass relationship between employee and the employee with a territory. This is the implementation of employee with a territory class. So each employee territory automatically receives the data fields and the methods of the superclass employee. We can add a new fields and a method to the newly created subclass. So here we extend employee, so we will have the employees two data fields, the salary, the ID, and the for set and the get methods for the two data fields. Then we added the new data fields and the new methods for employee with a territory class, which is an integer territory, and one is a get method and the other one is set method for retrieving and setting this data field. When you create a subclass by extending an existing class, the new subclass contains data and the methods that were defined in the original superclass. In other words, any child class object has all the attributes of its parent. Sometimes, however, the superclass data fields and the methods are not entirely appropriate for the subclass object. In these cases, you want to override the parent class members. To override a field or method in a child class means to use the child's version instead of parent version. Polymorphism in Java is a concept by which we can perform a single action in different ways. Polymorphism is derived from two Greek words, poly and morphs. The word poly means many, and the morphs means forms. So polymorphism means many forms. Method overriding occurs when a derived class has a definition for one of the member functions of the base classes. The base function is said to be overridden. When you override a parent class method in a child class, you can insert an override annotation just prior to the method. The override annotation lets the compiler know that your intention is to override a method in the parent class rather than create a method with a new signature. At override tags is not required. A program will work and properly override parent class method without any @override tags, but using the tags can help you prevent errors and serves as a form of documentation for your intention. When you create any object, as in the statement, some class and object equal new some class. When you instantiate an object that is a member of a subclass, you actually are calling both the constructor for the base class and the constructor for the extended derived class. When you create any subclass object, the superclass constructor must execute first. Then the subclass constructor executes. In this figure, we first have a public class A superclass. In A superclass constructor, we output the line in superclass constructor. Then we have a public class A subclass. Then this class extends A superclass. So A subclass is a child class. In its constructor, it displays one message in subclass constructor. Then we have a driver class demo constructor. Then in this main function, we instantiate a subclass child equal new a subclass. So on the right, this is the output of this program. So the message from the parent constructor will display first. Then the child constructor message will be displayed. When a superclass has a default constructor, like the constructor without argument, you can create a subclass with or without its own constructor. When a superclass contains only constructors that require arguments, you must include at least one constructor for each subclass you create. If all superclass constructors require arguments, that is, if the superclass doesn't contain a default constructor, then the first statement within each subclass constructor must call one of the superclass constructors. In other words, when a superclass requires constructor arguments upon object instantiation, even if you have no other reason to create a subclass constructor, you must write the subclass constructor so it can call one of the constructors of the superclass. The format of the statement that calls a superclass constructor from the subclass constructor is super, then you pass in list of arguments, though the keyword super always refers to the superclass of the class in which you use it. If a superclass contains only constructors that require arguments, you must create a subclass constructor, but the subclass constructor doesn't necessarily have to have parameters of its own. For example, suppose you create an employee class with a constructor that requires 3 arguments, a character, a double, and an integer, and you create an hourly employee class that is a subclass of employee. So the following code show a valid constructor for hourly employee. For hourly employee constructor, there's no parameter received. And we can just call the super, then we pass P, 12.35, and 40. So the superclass, the employee class constructor, will be called. You can have a different overloaded version of the employee constructor that pass 3 arguments. In either case, the super statement must be the first statement in any subclass constructor that use it. Super can be used to invoke immediate parent class constructor, as we show in previous slide. Super can also be used to invoke immediate parent class method. In this example, the public class customer, its constructor has 2 arguments, ID and a balance. Then the customer class also have a display method. Then we have a public class preferred customer, extend customer. So customer class is a superclass. Preferred customer is a subclass. And in preferred customer class, we have a data field, the discount rate. And in the preferred customer constructor, it receives 3 arguments, ID, balance. So the first statement in the constructor is a super, then we pass ID and balance. So it's a parent class, which is a customer class. The instructor will be called. The third rate we will assign to the data field discount rate. Preferred customer class also has a display method, so it overrides the superclass display method. In here, super.display, so it first calls customer's display method. Then it has a print out line. To add an extra line, says discount rate is the discount rate. Then the last one, test a customer, is a driver application. So in the main function, we first create one cust. One cust is the object of a customer class, and we pass 2 arguments, $124 and $123.45. Then preferred customer object, 1p cust, is instantiated, is created, and we pass the 3 arguments. The ID is 125, then the balance is $3,456.78. Then we also pass the discount rate, which is 0.15. So oneCust.display. OneCust is a customer class. It's an object of customer class. So display method in the customer class is executed. And the 1P class.display. So we'll go to preferred customer class and look for the display. So the first line super.display, that's in the customer display method, will be first executed. So it will output customer number, then ID number, balance. Then there's an extra line. After it has a system.out.println discount rate. So the discount rate will also be displayed for the object of a preferred customer. We can see the output on the right side. If a subclass has overridden a superclass method, for example, the display method in preferred customer has overridden the display method in the customer class, then super.display refers to the superclass version of the method, and both display and this.display refers to the subclass version. On the other hand, if a subclass has not overridden a superclass method, so the child can use the method name with a super or with this or alone. So in a subclass, the keyword this and the super sometimes refer to the same method, but sometimes they don't. It depends on if the subclass has overridden a superclass method or not. Conventionally, super keyword is used to access methods of the parent class, while this keyword is used to access methods of the current class. Why do we use class? It describes the idea of bundling data and methods that work on the data within one unit. That is why we use class in Java. This concept is also often used to hide the internal representation or state or an object from the outside. This is called information hiding. The general idea of this mechanism is simple. If you have an attribute that is not visible from the outside of an object, and bundle it with methods that provide read and write access to it, then you can hide specific information and control access to the internal state of the object. The student class shown in this figure is an example of a typical Java class. Within the student class, as with most Java classes, the keyword private precedes each data field, and the keyword public precedes each method. In fact, the forGet and the set methods are public within the student class, especially because the data fields are private. Without the public get and the set methods, there would be no way to access the private data fields. To change a student ID number, we cannot use some student.idnum equal 812, right? We cannot just assign an ID number to an object's ID number field. The ID number of the SumStudent object is not accessible in the main method that uses the student object because the ID number is private. Only methods that are part of the student class itself are allowed to order the private student data. To change a student ID, you must use a public method, so we can use the set IDNum method here. When a class serves as a superclass to other classes you created, your subclass inherits all the data and the methods of the superclass. This method in a subclass can use all of the data fields and the methods that belong to its parent, with one exception. Private members of the parent class are not accessible within the child class method. If a new class would simply extend your student class and get to its data field without going through the prop channel, information hiding wouldn't be operating. For example, suppose you create two child classes, part-time student and a full-time student, that extend the student class. If you want the subclass method to be able to directly access ID num and the GPA, these data fields cannot be private. However, if you don't want other non-child classes to access this data field, they cannot be public. To solve this problem, you can create the fields using the specify protected. So private is the most restrictive access modifier. If you use private modifier with an attribute or method, it can only be accessed within the same class. Subclasses or any other classes within the same or a different package cannot access this attribute or method. For protected attributes and methods can be accessed within your class by all classes within the same package and by all subclasses within the same or other packages. The protected modifier gets mostly used for internal methods that need to be called or overridden by subclasses. You can also use it to allow subclasses to access internal attributes of a superclass directly. Then public, this is the least restrictive access modifier. Methods and attributes that use public modifier can be accessed within your current class and by all other classes. Sometimes when you create a class, you might choose not to allow subclasses to override. So the three types of methods that you cannot override in a subclass are static method, final method, method within final classes. A subclass cannot override methods that are declared static in the superclass. In this example, we have a public class baseball player. That class has a public static void showOrigin method. And we also have a public class professional baseball player extends baseball player. So baseball player class is a superclass and the professional baseball player class is a subclass. In this subclass, we cannot override the showOrigins method because it is declared as a static in the superclass. Also remember the keyword super can be used in child class, non-static, and the instance method and constructors. So if we add a static in professional baseball player, the showOrigins with a public static void showOrigins, that's in the child class in professional baseball player. We cannot use a super here because super can only be used in child class. It must be non-static method. This code is valid here. So we have a public static void showOrigins. Instead use a super. We cannot use super here. We just called the superclass name. So we use a baseball player dot showOrigin. So the child class can access its parent non-private static method like this. So in the child class static method, we cannot use the keyword super. Instead, we should use the parent class name, a dot, and the method name to access the parent's non-private static methods. A subclass cannot override methods that are declared final in the superclass. For example, consider the basketball player and the professional basketball player classes in this figure. When you attempt to compile the professional basketball player class, we will receive the error message because the class cannot override the final display message method in the parent class basketball player. In Chapter 2, we learned that we can use the keyword final when we want to create a constant. We can also use the final modifier with methods when you don't want the method to be overridden. That is, when you want every child class to use the original parent class version of a method. In Java, all instance method calls are virtual method calls. That is, the method used is determined when the program runs during the execution, because the type of the object used might not be known until the method executes. When you define a method as a final method, the compiler will optimize the program performance by replacing some expanded code of the definition. So this process is called inlining the code, though it will make the program run faster and more efficient because the compiler knows exactly which version of method will be used. You can also declare a class as final. So if you declare a class as final, all of its methods are final regardless of which access modifier precedes the method name. And the final class cannot be a parent class. In this figure shows two classes, a hide and a go seek play class. That is the final class because we have the keyword final in the class header. And the professional hide and the go seek player class that attempts to extend the final class, adding a salary field. It will give us an error message because a final class cannot be a parent class. A concrete class is one from which you can instantiate objects. Sometimes a class is so general that you never intend to create any specific instance of the class. For example, you might intend never to create an object that is just an employee. An employee is more specifically a salaried employee, hourly employee, or contract employee. So we can define employee class as abstract class. Abstract class is a restricted class that cannot be used to create objects. We also have an abstract method. Abstract method can only be used in an abstract class, and it doesn't have a body. The body is provided by the subclass inherited from. An abstract class can have both abstract and the regular methods. To declare an abstract class or abstract method, you use the keyword abstract. In this example, we have a public abstract class animal. So abstract class animal means this class is abstract, which means no animal object can be created. Inside the class animal, we also have a public abstract void speak. Then you see that's a parenthesis, no argument for this method and a semicolon. We can see the abstract method doesn't have any implementation because it doesn't have a body, has no curly braces, no statements. So this method is abstract, meaning child classes must contain a speak method. The child class must implement this speak method. As we mentioned before, we cannot create an object. We cannot use the keyword new to instantiate an object from abstract class. We create an abstract class such as animal because we want to extend it. For example, because a dog is an animal, we can create a dog class as a child class of animal. The speak method within the dog class is required because we want to create dog objects, and the parent animal class contains an abstract speak method. So the speak method in dog class must exist. And you can create a dog object as dog my pet equal new dog Murphy because dog class is not abstract class. When you create a superclass and one or more subclasses, each object of each subclass is a superclass object. So in this example, we have a superclass animal, and we create the subclass cow extends animal. We also have a subclass dog extends animal. And in both cow and the dogs, we override, or we say we implement the speak method, because speak method is an abstract method in animal class. So in the subclass, they must be implemented and provided. As you are aware, when a superclass is abstract, we cannot instantiate objects of the superclass. However, we can indirectly create a reference to a superclass abstract object. A reference is not an object, but it points to a memory address. When you create a reference, you don't use the keyword new to create a concrete object. Instead, you create a variable name in which you can hold the memory address of a concrete object. So although a reference to an abstract superclass object is not concrete, you can store a concrete subclass object reference there. In the bottom left, we see the public class animal reference. In the main function, we have an animal, then animal ref. So animal ref is not a concrete object. It's just a reference to the superclass animal. Here, no superclass animal object is created, and they cannot be created because animal class is an abstract class. Instead, we see animal ref equal new cow and animal ref equal new dog. So dog and the cow objects are created using the keyword new. When the cow object is assigned to the animal reference, the animal ref dot speak method results in moo, that's in the cow class. When the dog object is assigned to the animal reference, the method animal ref dot speak results in wolf, because it called the speak method in dog class. We can see the results in the output. So this example also demonstrates polymorphism, right? We have the same speak method but behave differently. We also see the Java's ability to select the correct subclass method depending on the argument type is known as a dynamic method binding. Dynamic method binding is most useful when you want to create a method that has one or more parameters that might be one of several types. For example, here we have a talking animal method. It accepts any type of animal argument. The method can be used in programs that contain dog objects, cow objects, or objects of any other class that descends from animal class. The application passes first a dog, then a cow to the method. So here we have a dog.setName Ginger. So the dog's name is Ginger. So when called talking animal, we pass dog. It will output come one, come all, see the amazing talking animal. The Ginger says wolf, and we will animal.speak will call the dog method, and it will show wolf. Similarly, when you pass cow as an object, the cow's name is Molly. So it will show Molly's name, and the cow's class speak method will call, so moo will be output. When you create an array in Java, you are not constructing objects. Instead, you are creating space for references to objects. In other words, although it is convenient to refer to an array of objects, every array of objects is really an array of object references. When you create an array of a superclass references, it can hold subclasses references. This is true whether the superclass in question is abstract or concrete. In this example, animal square bracket. So that means it's an array. animal square brackets, animal ref equal new, animal 3. So the statement creates an array of 3 animal references. Each element of the array is a reference, and then can reference an instance of the dog or cow or snake object. Those objects are instantiated, and their reference is assigned to each array element. So after the object references are in the array, you can manipulate them like any other array elements. We see the for loop, integer x equals 0, x less than animal ref dot length plus x. So it loops through in a subscript to get each individual reference to speak method. On the right, we can see the output of this application. The array of 3 references is used to access each appropriate speak method in their own class. Object class is present in java.len package. Every class in Java is directly or indirectly derived from the object class. If a class doesn't extend any other class, then it is direct child class of object. And if it extends other class, then it is an indirectly derived. Therefore, the object class methods are available to all Java classes. Hence, object class acts as a root of inheritance hierarchy in any Java program. The object class include methods that descendant classes can use, overload, or override. This table describes the method built into the object class. Every class you create has access to this method. ToString method provides string representation of an object and used to convert an object to string. Within class, if you don't create a ToString method that overrides the version in the object class, you can use the superclass version of the method. For example, we examine the animal and the dog classes here. Notice that neither the animal class nor the dog class defines ToString method, but we still can use it. In the display dog class, we see my dog.toString, and we assign ToString docstring. The output consists of the class name of which the object is an instance, dog, the @sign, and the hexadecimal identifier. The identifier is an example of hash code, a calculate number used to uniquely identify an object. Even if 2 objects in an application have the same Java identifier, for example, the same identifier is used in different methods, each will have a unique hash code. Instead of using automatic ToString method with your classes, we see in previous slide, the automatic ToString class doesn't give much information. We can supply our overloaded version ToString method, so it will give the useful information of the object. For example, in here we have a bank account class, and this class have an account number and a balance. In the ToString method, we output the string information about the bank account number, and the balance. In the constructor public bank account, we mistakenly assign the number to the balance. So if this error happens, we can use the ToString method to detect the error, because the ToString method will return the object information. We can create a short application such as the test bank account here. So this application uses the bank account class ToString method to display the relevant details of a bank account object. We also have a equals method. Equals, then you pass the object that compares the given object to this object. This object means which the method is called. It gives a genetic way to compare objects for equality. it is recommended to override equals method to get your own equality condition on objects. Though this method returns a Boolean value indicating whether the objects are equal. This equals method considers two objects to be equal only if they have the same hash code. In other words, they are equal only if one is referenced to the other. For example, two bank account objects named my account and your account are not automatically equal, even if they have the same account numbers and balances. The inherited equal method returns true only if they have the same memory address. If you want to consider two objects to be equal only when one is a reference to the other, you can use the built-in object class equals method. However, if you want to consider objects to be equal based on their contents, you must write your own equal method. You must override this built-in equal method. In this public class bank account, we override the equals method. So here, this equal method takes a bank account argument, right? And inside the body, we have an if statement. If account number equal second account dot account number, and the balance equals the second account balance, then the result is true, otherwise it's false. So this equals let us to compare the contents of two bank accounts. We know inheritance represents the is-a relationship, which is also known as a parent-child relationship. There are many advantages of inheritance, like for method overloading, that the runtime polymorphism can be achieved. It promotes reusability. When a class inherits or derives another class, it can access all the functionality of inherited class. Reusability and enhanced reliability. The base class code can be already tested and debugged. As the existing code is reused, it leads to less development and maintenance cost. Inheritance makes the subclasses follow a standard interface. It reduces code redundancy and supports code extensibility and facilitates creation of class libraries. The capability to inherit from more than one class is called multiple inheritance. Many programmers consider multiple inheritance to be a difficult concept. There is an alternative to multiple inheritance, interface. An interface is a completely abstract class that is used to group related methods with empty bodies. Let's see this example. On the left, we recall that the animal and the dog classes from previous slide. So animal is the superclass, dog is the subclass, the dog extends animal, and the speak method in the dog overrides the method in the animal class. On top right, we create a worker interface, public interface worker. And this example gives the work interface a single method named work. So here it says public abstract void work. There's no implementation in the interface worker definition. When any class implements worker, it either must include a work method or the new class must be declared abstract. Then its descendants must implement the method. The working dog class extends dog and implements worker. A working dog contains a data field that a regular dog doesn't, an integer that holds hours of training received. The working dog class also contains get and set methods for this field. Because the working dog class implements the work interface, it also must contain a work method. In this example, the work method calls the dog speak method and then produce two more lines of output, a statement about working and the number of training hours. So in this public class, working dog extends dog. So we inherit from superclass using the keyword extend. And we implement, the keyword implements worker. So it will implement the interface. So we can compare abstract classes and the interfaces as follows. Abstract classes and interfaces are similar in that you cannot instantiate concrete objects from either one. So we cannot instantiate objects from animal or from worker. Abstract classes differ from interfaces because abstract classes can contain non-abstract methods. In class animal, we can see the speak is abstract method, but the get name and the set name, they are non-abstract method. However, in the interface worker, the work is abstract method, and the interface can only contain abstract method. The third difference is that a class can inherit from only one abstract superclass. So if you extend, you can only extend one abstract superclass, but it can implement any number of interfaces. So you can implement multiple interfaces. Interface can contain data fields, and those data fields must be public, static, and final. It makes sense they cannot have private data fields because interface cannot contain method bodies. So without public method bodies, if you have a private data, there's no way to retrieve those data. Also, it makes sense that the data fields in an interface are static because you cannot create interface objects. Finally, it makes sense that interface data fields are final because without methods containing bodies, you have no way other than at declaration to set the data fields values, and then you have no ways to change them. Your purpose in creating an interface containing constant is to provide a set of data that a number of classes can use without having to redeclare the value. In this example, we have a public interface pizza constant. So there are several constants are declared for pizza. And in the public class, pizza demo implements pizza constant. So this demo can directly use those constants declared in the interface. An anonymous inner class is a class that has no name and is defined inside another class. You create an anonymous inner class to save some work when you need a single class that is instantiated only once in a program. You use the new operator to create an inner class and to simultaneously create an instance of it. The instance either extends a superclass or implements an interface, but you don't use the keyword extends or implements when defining the class. In this figure, it contains a program that demonstrates using anonymous inner class. The program prompts the user for the capacity of a washing machine. Rather than create a separate file to define a class named washing machine and have it implement worker, so the program creates a washing machine object without naming a class for it. So it says worker, washing machine equal new worker. Then the curly braces, inside the curly braces, it overrides the work method in the work interface. And see, there's a semicolon after the closing curly braces. So those are definition for the anonymous class. Washing machine dot work is the call to the work method. A lambda expression creates an object that implements a specific type of interface known as a functional interface. A functional interface is an interface that contains just one abstract method. So the worker interface, we only have work, abstract work method. so the work interface qualifies as a functional interface. This program demonstrates a Lambda expression. When the interface contains just one abstract method, you don't need to create an anonymous class. Instead, you can just create an object that implements the interface directly. The washing machine object implements the work interface. Because the interface contains only one method, the Lambda expression knows to use that method. So here we have a worker, washing machine, equal sign, then round parentheses. The empty round parentheses indicate that work method takes no parameters. If it did, you could list the arguments separate by comma between the parentheses. The Lambda operator is composed of two characters, a minus sign and a greater than sign. The code to implement the method is placed between the curly braces. If the implementation requires only one code line, then the braces could be omitted. Package in Java is a collection of classes, subpackages, and interfaces. It helps organize your classes into folder structure and make it easy to locate and use them. More importantly, it helps improve code reusability. So each package in Java has its unique name and organizes its classes and interfaces into a separate namespace or name group. Creating a package is a simple task. First, we choose the name of the package. So in this example, we say package P1. P1 is the package name, and it must be the first line of the code in your Java source files. So the package statement must be the first line of the code, and after that, we have the implementation of a class or methods. Then we save this file as a .java file. For example, we save as a demo.java. Then we compile the file. The compilation is completed. A class file is created. However, no package is created, so next step has the solution. Now we have to create a package. So this command javac -d then .demo.java. This command forces the compiler to create a package. The dot operator represents the current working directory. So when you execute the statement, it creates a package P1. When you open the Java package P1, inside you will see the C1.class. The one single dot is saved in the current directory. If you want to save in the parent directory, you use a double dot. So java c-d .demo.java. So the file will be saved in parent directory. To reuse and import the package, so the syntax is that you have an import keyword, then you provide the package name. In the Java programming language, a package or class library is often delivered to user as a Java archived file, JAR. So JAR file compress the data they store, which reduce the size of archived class file. The JAR format is based on the popular zip file format.